What happens if you have a triangle that is not a right triangle? Let's talk about non-right triangles. Triangles still have angles adding up to 180, no matter what, or pi if you want, but we're back in degrees talking about this. So there are two things that we use to work on non-right triangles. There are many more, but two of them that I'm going to talk about. First one is called the law of sines. The law of sines. The law of sines is written this way. It is written as the sine of the angle A over the length of A is equal to the sine of the angle B over the angle B is equal to the law of this, or is equal to the sine of the angle C over the side length C. Now, if you have labeled triangles the same way all the time, and that almost looks like a right angle, it is not. But if I label this one A, this one B, and this one C, then this angle is C, this side opposite it is C. This angle's B, the side opposite it is B. Here's the angle A, and its side opposite is lowercase a. So there's the relationship among those 6 items. You can feel free at any time to take the reciprocal of these. So you could write this as A over sine of A, B over sine of B, C over sine of C, as long as they're together. So that is one way to work on what's called a non-right triangle. The other way that we're going to work on them is called the law of cosines. Now there's a law of tangents and all that kind of stuff, but these two are sufficient. So law of cosines. When I show you the law of cosines, you will probably recognize that it is very much like the Pythagorean theorem. It's got a little bit of a twist, but it comes in 3 forms, and if you see the pattern, it's pretty easy to distinguish which is which. But if I've got the side length A, I say A squared is equal to B squared plus C squared. There's the look that's like the Pythagorean theorem. But then we say minus 2, and then A and or B and C, 2BC, and then here's where the cosine comes in. Cosine of the angle A. So there's my pattern. Let me do this again. If I put B squared here, I've used B, so I have A squared plus C squared. Then I subtract 2 AC, and then cosine of B. Just to beat a dead horse, so to speak, we're going to do this one. B squared plus A squared minus 2BA, or AB, cosine of the one over here, which is C. So there are the 3 forms of the law of cosines. Now, when do you use which one? Well, I'm going to give you some general ideas, and then we're going to have some examples. So basically, and this is just basic information, it is not guaranteed all the time, but basically you use the law of sines when you have an angle and the side opposite it. Now you likely will never have more than one of those, but if I have, like, if I've got angle C and I've got the side opposite it, or if I've got angle A and the side opposite it, so that's the ideal time to use the law of sines. Basically, you use the law of cosines when you have, like, first of all, maybe all three sides. Or, and this is getting back to some geometry stuff which you may or may not have studied, but if you've got an item called side angle side, which is, let me show you an example here. Let's say we've got this triangle. If this is side A, this is side B, and this is side C, so this would be angle C. This one over here would be angle A, this would be angle B. Okay, if I have side angle side, would mean I'd have like these three things. This side, the angle between them, and the side. So that's what side angle side is. B, A, and then lowercase c. So if you've got side angle side, or if you have all three sides. So those are some kind of general ideas. They are not hard and fast, and sometimes you have to use both. So anyway, there is a little bit of information. Now I'm going to give you an example, and we're going to try to use one of them. The first example that I have is this. I've got the angle C is equal to 50.15 degrees. I've got the angle A is equal to 106.1 degrees. And I've got the side C is equal to 3,726 feet. So there's a triangle that is described in just in numbers, not in pictures, and we have to decide what we're going to use. Well, if I come back up here, notice I have an angle and the side opposite it. I've got the C parts. So that's when I use law of sines. And not only law of sines, but I'm also going to use my calculator quite a bit here. So we've got to keep that in mind. All right, so I like to draw pictures, and so I'm going to try to do that. I've got to have a 106.1 degree angle, so that's bigger than a 90, and then I've got to have a 50 something. So let me do this. And obviously these are not exact by any means, but I'm going to call this angle A and this one angle C. So here's side C. So this is 3726. Here's side or angle A, which is 50.15, and I have no idea the length of that one. It looks, if my graph is anywhere near accurate, it looks like A is a whole lot longer than C. And then here are the pieces for B. Let's go ahead and solve the triangle. That's usually the task, either that or there's a word problem involved. But one thing that we need to do to solve the triangle. So solve the triangle. We need all three sides and all three angles. Well, we've got two of the three angles, so that's kind of nice. So B is going to be equal to, these add up to 180, so let me just take 180 minus 50.15 minus 106.1. Now you can do that with a calculator, and just to deal with that, I will do it with a calculator. So let's take this, and we've got 180, put this where you can see it, minus 50.15, so minus 50.15, this is not in degrees, minutes, and seconds, so I can just do it on the calculator kind of simply, minus 106.1. Whoops, what did I do wrong? I did something wrong. 106.1. Okay, I see what I did wrong. I hit the wrong button, didn't I? So let me fix that. So let's do this. Okay, so 23.75. So that tells me that angle B is 23.75. Now, we could have done that by hand. That would have been just fine. But anyway, there's that. Now let's set up the law of sines. So since we've got those two, we're going to use the law of sines. Law of sines looks like this. And I want to note what we're looking for. We have the angles. We do not have the sides. So I'm going to take the reciprocal version of this so that I have the sides on top. Denominators are harder to work with than numerators, so I'm going to do that. Let's look at this. If I take sine, or A over sine A, well, I don't know what A is, so I'm going to just write that as A. The sine of 106.1 is equal to B over sine B. I don't know what B is. The sine of 23.75. And then I've got equals C over sine C. I actually know both of those. I've got 37.26. I'll leave the label of feet off of it for now. The sine of 50.15. So here's what I've got. Now I've got two equal signs. That's not terribly useful in terms of solving, but the goal here is to take one of these fractions with another one of these fractions, set them equal to each other, and make sure that you've got one unknown value that you can solve for. So I'm going to start by taking this group. That group has a b that's unknown. So we're going to find out what b is. I'm going to cross multiply and work the problem. So here's what I've got. Actually, I don't need to cross multiply. I've got b on top, don't I? So let me just multiply both sides by sine of 23.75. So I'm going to have b is equal to 37.26 times the sine of 23.75, and it's all over sine of 50.15. So there's my value for b. Now before I get my calculator out and do this, I'm going to set up a also. So let's take this one together with this one. That will have only one unknown. Use the things that were given as much as possible rather than the things you get. That will keep you more accurate. This is going to give me a big fat decimal and it's not as accurate. So if I use the items that I was given, that will give me more accuracy. So using these, I've got this. Multiply both sides by sine of 106.1. So A is equal to 37.26 times the sine of 106.1 over the sine of 50.15. So we started out, we were given 3 parts out of 6 of our solving the triangle. We found a 4th part. That was one thing we needed. And this should give us the 5th and the 6th part of the triangle. Now, I need a calculator to do this. This is not something that you just do in your heads. So I've got to put my calculator in degrees. And now I'm going to go in and just set this thing up. So here's what we've got for the first one. We've got 37.26 multiplied by the sine of 23.75. So the sine of 23.75, and I've got my calculator in degrees, so I'm fine with that, divided by, now the sine of, so the sine of 50.15, close that up, and we've got 1954.651587. When we've got the lengths here, we've got one example. It is rounded to the nearest foot. It's got 4 significant digits if you want, so I will do that here. So I'm going to say that this is approximately equal to, and I could put decimals, so 1954.651587 0.651587. Now that there are a lot more decimals, the calculator just can't give them to me. So I'm going to say B is approximately, and I'm going to take 1955, round up, and this is measured in feet. So there's the one I'm going to use for that. Now the last answer we've got to have for A, so let me take 3726 multiplied by the sine of 106.1 and then divide by the sine of 50.15. 50.15, hit enter. So this is approximately 4662.952038. Again, we're going to use 4 significant digits. So I'm going to say A is approximately 4663 feet. So we have solved a triangle using the law of sines. Now that's generally a little bit more work than solving a right triangle, but the law of sines at least gives us a way to do that. Got one more example. Let's try another example here. So our next example has this. It's got a triangle kind of drawn. So let me draw my triangle, and I'm going to label this B, this A, this C. This one is 76.0. It's, I haven't labeled it as feet or inches or whatever. It's just 76.0, so it's got 3 significant digits. I've got the angle A is equal to 27.2 degrees. And I've got the angle C is equal to 115.5 degrees. So this one is very closely related to the last one because we've got 2 pieces of information that are related. We've got C, angle C, and we've got side C. So again, law of sines. We're trying to solve the triangle. So solve the triangle. That's the instruction here. So let's set it up. Once again, I have a bunch of information that is similar to the last problem that we did. So this is just kind of a repeat with a different problem. We've got 2 out of the 3 angles. So we could say that B is equal to 180, that's the total, minus 27.2 minus 115.5. Okay, so if I do that, I'm going to be lazy and use the calculator here. 108, yeah, it would help if I did it right. Okay, let's see, 180, yeah, minus 27.2, and then minus 115.5. So we've got 37.3. So there's our angle B, so that's part of our result. Now, next thing we've got to do is set up the law of sines. Got it set up basically the same as before. The angle opposite B, or the side opposite B, the side opposite A, right there, and this is C. So I've got C and angle C. Let's see. I'm going to put A over the sine of A. 27.2 is equal to B over the sine of B. Sine of 37.3 is equal to C, which is 76.0, over the sine of 115.5. So I've got to do something similar to last time. Take 2 of these fractions where there's only one unknown. I would not take these 2 together, not ever, if I don't have to. So these 2, I'm just going to multiply both sides by sine 37.3. So I get B is equal to 76.0 times sine of 37.3 over the sine of 115.5. And these are packages, remember that. So you've got to actually calculate them. You don't do anything with the angles or anything like that. Then I'm going to take this one together with this one. So I'm going to say A is equal to 76.0 times the sine of 27.2, 27.2 over the sine of 115.5. So calculator time. Let's see what we get. I've got my calculator in degrees still. Notice it's in degrees. So here I'm going to clear this out. Let me take 76, calculator doesn't care about the zero, multiply by sine of 37.3, so times the sine of 37.3, and then I'm going to divide by the sine of 115.5, and I get 51.0257, 51.05257.803. So we're going to say B is approximately, and this was 3 significant digits, so 51.0. This one, 76 times the sine of 27.2 divided by the sine of 115.5. So we end up with this approximately 38.4888. You're not seeing the answers here, sorry about that. And then 199, let me set them over here, 199. So I'm going to say that A is approximately 38 point, this is 5, rounded up because of that 8 that's, or the 8 here. So now we've got a value for A, a value for B, we were given a value for C, we've got all three angles, all three sides, we're done solving the triangle.